Hello and welcome to SigmaXL video tutorials. Today we'll be taking on the Traveling Salesperson Problem, or TSP, in DiscoverSim version 2.1. The Traveling Salesperson Problem asks the following question. Given a list of cities and the distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the origin city? The problem was first formulated in 1930 and is one of the most intensively studied problems in optimization. It is used as a benchmark for many optimization methods. The TSP has several applications such as planning, logistics, and the manufacture of microchips. We will now consider a 30-city TSP problem. The data is from City Distance Dataset HA30, which describes the airline distances in hundreds of miles between 30 international cities. A 30-city problem has 29 factorial divided by 2 possible solutions. That is 4.4 times 10 to the power of 30, a very large number. So obviously this is not something that can be solved using the discrete exhaustive option in DiscoverSim. The goal is to achieve the best known solution minimum of 503. Or 50,300 miles. In DiscoverSim version 2.1, the genetic algorithm has improved handling of the DSIM is all different function, so we will use the genetic algorithm to solve this TSP problem. The DSIM is all different function will be used in a constraint in order to ensure that the only solutions considered are unique city sequences. To open our dataset, click DiscoverSim, Help, Case Studies, and then find the file 30 International Cities TSP.xlsx. This is a matrix showing the distance between cities in hundreds of airline miles. The city names are shown in column B and row 3. DiscoverSim discrete input controls will be created in cells C36 to AE36. The output, total distance traveled, will be specified in cell B40. A constraint will be added at cell B42 that references a DSIM is all different function at cell B41. Excel's offset function is used to extract the city names and distances for the selected input control values. Row 37 shows the names of the tour cities in the order visited. Row 38 shows the distances between the tour cities. Click cell 36 and select Control. Click the input name cell reference and specify cell C35 containing the input control name first. Select Discrete and ensure the value for step is equal to 1. Set the min value to 1 and the max value to 29. There are 30 cities, but the first city is defined as Azores, so only 29 need to be solved. Click OK and hover the cursor over cell C36 to view the comment displaying the input control settings. With cell C36 selected, click the DiscoverSim Copy Cell menu button. Select cells D36 through AE36. Click the DiscoverSim Paste Cell menu button. Review the input control comments in cells D36 through AE36. We will now specify the output in cell B40. Note that the cell contains Excel formula for total distance traveled. Select Output Response. Enter the output name as distance. We will not enter any specifications. Click OK and hover the cursor over cell B40 to view the DiscoverSim output information. Click on cell B41 and select DiscoverSim DSIM function. Select the category group DiscoverSim and choose the function DSIM is all different. Click OK. Select the cell range of C36 through AE36. Once again, click OK. The DSIM function formula is now in cell B41, which returns a 1 since the default input control values are all different. We will now add a constraint that references the DSIM function. Click on cell B42 and select Constraint. Enter B41 in the left-hand side, or LHS, or click the LHS cell reference and select B41. Select Equal to, and enter 1 in the right-hand side, or RHS. Click OK and review cell B41. This constraint will ensure that the optimization will only consider a single unique value for each city as defined by the TSP, where each city is visited only once. We are now ready to perform the optimization. Select DiscoverSim, Run Optimization. Select Minimize for Optimization Goal, Weighted Sum for Multiple Output Metric, and Mean for Statistic. Select Genetic Algorithm. Set replications to 2 and set the seed value to 1, 2, 3, 4 in order to replicate the optimization results shown in this video. Leave the remaining settings at their default. Since this is a deterministic problem, we technically only need a single replication, but DiscoverSim requires a minimum of 2 replications for internal consistency on stochastic problems. Click Run. This optimization will take approximately 4 minutes. I've increased the flow of time for the sake of this video. To save time, when the solution reaches the best known value of 503, click the Interrupt button. As discussed in the beginning of this video, the final solution of 503, or 50,300 miles, is the best known solution for this 30 international city problem. We can see that all of the values are all different, satisfying the constraint using DSIM is all different, and the amount violated is 0. You are prompted to paste the optimal values into the spreadsheet. Click Yes. This replaces the input control values in cell C36 through AE36 with the optimum values. And this will provide us with the final city tour in cells B37 through AF37. If one wanted to evaluate flight times with uncertainty rather than distances, then input distributions could be added to create a stochastic model. Another example of where the DSIM is all different function would be used in a constraint is stochastic job scheduling with due dates. Here's a 3-dimensional graphical view of the final solution. This concludes the DiscoverSim tutorial video, The Travelling Salesperson Problem. For more videos, go to SigmaXL.com or join us at our YouTube page. Thank you for watching.